Hello, this is A-Level Preparation course by me, Kothar, and we're going to talk about biological molecules, and this is part 1 of it. So, we got essential substances, and we got essential substances of 92 in total. And living things are based on a total of 16 elements from those 92. And almost 100% of all the biomass of organisms is composed of just 4 key elements, and those are carbon, hydrogen, oxygen, and nitrogen. So we got carbon, hydrogen, oxygen, nitrogen are essential in our bodies, all of us, all kind of organisms. But the most important element of all these 4 is carbon. So now we're going to talk about the properties of carbon. So carbon is the most important element from those 4. Why? Because it has such properties, it makes it the best. Why? Carbon atoms bond with each other in long chains. So they form long chains. Long chains. And these chains can be branched or even joined up as rings. So they become rings. And they have ability to join with other important, or should I say, to bond with other important elements. So we say the ability to bond with other elements. The ability to bond with other elements, excluding electrons. To bond with other elements, and with excluding electrons. So this linking excludes electrons, which is essential in critical properties to contribute to the diversity of life in this earth. We got other important elements, but I'm going to talk about only these 2. Aside from carbon, there are 2 elements that can be destructive at the same time important. Imagine, those are the sodium atoms and chlorine atoms. The properties of these 2 are destructive and can kill cells, but when they are ions, they are essential. They are vital to the survival of the organism. They're essential. Okay? So now we're going to talk about carbohydrates. So, carbohydrates. So dear student, this stuff will come up in the AS exam, and I'm sure about it because it's one of the most important topics in the whole A-level preparation course. So carbohydrates contain 3 elements, and as you know, these 3 elements are one of the most important electrons in those 4. So they are the carbon, it is the hydrogen, and of course the oxygen. And carbohydrates are formed in 3 types of formation, like 3 forms. So the first one is monosaccharides, and I think you guys know it. Monosaccharides. The second one, more complex than it, that is the saccharides. And the third one, which is more complex, that is the polysaccharide. One example of monosaccharide, all of us know, is the glucose, the saccharide is the sucrose, and polysaccharide is the starch. So now we're going to talk about the general formation, not general formation, but the general formula of monosaccharide. So let's clear this up. So carbohydrates are made of 3 forms. monosaccharide, disaccharide, and a polysaccharide. And now the basic one is the monosaccharide, so we're gonna write 1, and you know it's the mono. We can just write mono. And we got a general formula. It's CH2O N. Okay, and this N is in the range of number between 3 and 9. Okay, so they're classified according to the number of carbon atoms. I should know that. And the monosaccharides will have fall into these, and all the monosaccharides fall into 3 categories. Okay, not 3, 4 actually. We got C, which equals to 3, and that is a triose. C, which equals to 4, and that is a tetrose. And C equals to 5, and that is a pentose. It sounds like a gum. And C equals to 6, and that is a hexose. So let's review this again. This is the general formula of monosaccharide. CH2O parentheses N. And these N fall in these numbers between 3 and 9, okay? And they are classified according to the number of carbon atoms. And monosaccharides are gonna be falling in these 4 categories. And that is C, which equals to 3, triose, C equals to 4, tetrose, C equals to 5, pentose, and C equals to 6, hexose. This is clear, I guess? So now we're gonna define each triose, a triose, tetrose, pentose, hexose, okay? So let's clear this up. So I think now we're gonna go to part 2. Thank you for watching.